Guys, welcome to this channel. Always make sure you subscribe, comment, and then you'll get more of our videos as we continue to do this work. Alright, we're going to look at wave motion today. We have a question here. The diagram below shows a waveform. Calculate the speed of the wave. This is the diagram. Okay? Now we're saying that from this point to this point, the time check is 0.6 seconds. Then we give the distance from this point to this point, say 9 meters. The question says, find the speed of the wave. Before we can do that, we have to redraw the diagram here on the solution area. We'll redraw the diagram. We know that from this point to this point is one cycle. And from here is another cycle. So in the time of 0.6 seconds, the wave actually covers 2 cycles. Alright. So we have to check the wavelength from this point to this point is 1 time the wavelength, 1 cycle. From this point to this point, if we add this 1 there, it becomes 2 times the wavelength. Then from here to the end of it, we have 3 times the wavelength. So we are saying that in this distance, 9 meters, the wave cover, this distance, we have the wavelength will be 3 times lambda. Okay, let's see the speed of wave. The formula V equal F times the wavelength, and this speed let's call lambda. We do not have the frequency value, neither do we have the wavelength value. Then they're asking us to find the speed. So we have to find the frequency, find the wavelength, and then we can find the speed. The frequency is the number of cycles per time. So the number of cycles that actually cover this time is 2 cycles, because from here is 1 cycle, here is another cycle. So from here we have 2 cycles. So the number of cycles is 2, and the time check is 0.6 seconds. If we divide this, we get 3.333 per second. Now the SI unit for frequency is hertz, but then in this case we can use per second, which is one of the units, but not the SI unit. Okay, we are left to find the wavelength. We know that the distance here is 9 meters, and the wavelength, to find the wavelength, we already have 3 times the wavelength here, because we have 3 cycles. We have 1, 2, and the final area is 3. So it becomes 3 times the wavelength. So 3 times the wavelength is equal to the distance which the wave traveled. So 3 lambda equal 9. We want to find lambda, so we divide both sides by 3. Of course, we have 3 meters. So the wavelength is 3 meters. From there, we can now find the speed of the wave. So the speed is equal to the frequency multiplied by the wavelength. So the frequency is 3.3333, and then the wavelength is 3. So if we multiply that again, the speed will be 9.9999 meters per second. That is the answer. But then we can also write this answer to the nearest whole number. So if we want to take it to the nearest whole number, we are going to take 1 from here, out of here, and discard the rest of the numbers there. So if we take 1 out of here, it becomes 10, and we discard the rest of the number. So you can get this answer. If your teacher or your examiner tells you to leave your answer to the nearest whole number, you give them this. This one is correct to the nearest whole number. So this is the answer to the question. So you either use this or this one if you are not restricted. But if you are restricted, say leave your answer to the nearest whole number. This. Why if they say leave your answer to 2 decimal? After the decimal point, you have 2 numbers here. So you have to add 1 to make it 10. So to 2 decimal places, here you take 1 from here, add it here to make it 10. So this is 10, suppose you add 1 here. So it will be 9.100. 9.10. That will be the answer. 2 decimal places. Thank you for watching.